Welcome to aminacademy.com. In operation research, let us discuss about linear programming models. A model which is used for optimum allocation of a scarce or limited resources to competing products or activities under such assumptions as certainty, linearity, fixed technology, and constant profit per unit is linear programming. Linear programming is one of the most versatile, powerful, and useful techniques for making managerial decisions. Linear programming technique may be used for solving broad range of problems arising in business, government, industry, hospitals, libraries, etc. Whenever we want to allocate the available limited resources for various competing activities for achieving our desired objectives, the technique that helps is linear programming. As a decision-making tool, it has demonstrated its value in various fields such as production, finance, marketing, research and development, and personal management. Determination of optimal product mix, that is a combination of products which gives maximum profit. Transportation schedules, assignment problem, and many more. Optimization is the way of life. Every person wants to optimize his life and products. We all have finite source and time, and we want to make the most of them. From using your time productivity to solve supply chain problems for your company, everything uses optimization. It is an especially interesting and relevant topics in operation research. It is also very interesting topic. It starts with simple problems, but it can get very complex. For example, sharing a bar of chocolate between siblings is a simple optimization problem. We don't think in mathematical terms while solving it. On the other hand, devising inventory and warehousing strategy for an e-tailer can be very complex. Millions of SKUs with different popularity in different regions to be delivered is defined time and resources. Linear programming, that is LP, is one of the simplest way to perform optimization. It helps you to solve some very complex LP problems and linear optimization problem by making a few simplifying assumptions. As an analyst, you are bound to come across application and problems to be solved by linear programming solution. What is linear programming? Linear programming is a simple technique where we depict complex relationships through linear functions and then find the optimum points. The important word in the previous sentence is depicted. Application of linear programming are everywhere around you. You use linear programming at personal and professional fronts. You are using linear programming when you are driving from home to work and want to take the shortest route. Or when you have a project delivery, you make strategies to make your team work efficiently for on-time delivery. Let us discuss about some with examples of linear programming problems. Some courier company, look at this example. Some courier company's delivery man has 6 packages to deliver in a day. The warehouse is located at a point A, here the warehouse. The 6 delivery destinations are given by U, V, W, X, Y, Z. These are the destinations. The numbers on the line indicates the distance between them in kilometers. Like here, from this is a warehouse, this is a location to be the goods to be delivered. The distance is given everywhere here. To save the fuel and time and delivery, the person want to make the shortest route. Here there are 6 destinations is there. From that 6 parcel, goods to be delivered each one, then which is the shortest route. Suppose somebody can go this way, deliver 1, 2, 3, and from here and go here, like any way he can choose this way, any different ways he can choose. But how to choose a shortest way? Here the help LPP. So the delivery person will calculate different routes for going to all the 6 destinations and then come up with the shortest route. This technique of choosing the shortest route is called linear programming. In this case, the objective of the delivery person is to deliver the parcel on time at all 6 destinations. The process choosing its best route is called operation research. Operation research is an approach to decision making which involves a set of methods to operate a system. In this above example, my system was the delivery one. It is an oversimplification as the real route would not be a straight line. It would like have multiple turns, U-turns, signals and traffic jam. But with a simple assumption, we have reduced the complexity of the problem drastically and are creating a solution that should work in most scenarios. Now we'll formulate this is the, here by using this scenarios, we can formulate an equation LPP and solving them and find the shortest route. Now we'll do some another example to understand this concept. Example, consider a chocolate manufacturing company that produces only 2 types of chocolates, A and B. Both chocolates require milk and choco only. The raw materials are milk and choco only. The manufacturer, each units have A and B. 2 units are there, A and B. The following quantities are required. Each unit of A requires 1 unit of milk and 3 units of choco. Each unit of B requires 1 unit of milk and 2 units of choco. The company kitchen has a total 5 units of milk and 12 units of choco. On each sale, the company makes the profit of rupees 6 per unit A sold and rupees 5 for unit B sold. These are different constraints given. Now the company wishes to maximize its profit. How many units of A and B should be produced respectively? Here 2 units are there and raw product is milk and choco, and profits also given. Here combined together we have to formulate a equations, linear equations. Now the company wishes to maximize the profit. How much units A and B should be produced respectively? Here we have to make a table. This is a very simple table. Here, look, this is a product milk and choco. Here the A and B have 2 units. Now choco in A unit, choco is 1 unit and milk is 3. And B, choco have 1 unit and here here profit per unit is given, and this here the table is given profit is 6 and profit is 5 for A and B respectively. Now look at here, let the total number of units produced by A equal X. Let it be variable X. The total number of units produced by B is Y units. Now the total profit is represented by Z. The total profit of a company is given by the total number of units A and B produced multiplied by its per unit profit. Look at here. So here there are profit for X unit is 6X, profit for Y unit is 5Y, because there are 5, profit is 5 for Y product. So therefore profit is Z equal 6x plus 5y. And with mean we have maximized Z. That means our maximizing equation is Z equals 6x plus 5y. The company will try to produce as many units of A and B to maximize the profit, but the resources of milk and choco are available is a limited amount. As per the above table, each unit of A and B requires 1 unit of milk, and the total amount of milk available is 5 units. To represent this mathematically, look at here, x plus y is lesser than 5 because available total units of choco is 5. Therefore, here we can say x plus y is lesser or equal to 5. This is a limiting equation. And also, each unit of A and B requires 3 units and 2 units of choco respectively. The total amount of choco available is 12 units. To represent this mathematically, 3x plus 2y is lesser or equal to available unit of choco is 12. So it's not more than 12. This is 3 into x plus 2 into y is lesser or equal to 12. Also, value for unit A can only be integers because there is no negative constraints. So we have 2 more constraints. X is greater than or equal to 0. Number of unit x and y should be greater than zeros because number of units of is not in negative, because the co and milk units are in positives. For the company to make maximum profit, the above inequalities have to be satisfied. This is called formulating the real world problem into mathematical model. We got these all equations. We write all the equations combined together and solving by graphically or some other ways you can solve. Common terminologies used in linear programming. Let us define some terminologies used in linear programming using above examples. Here, first, decision variables. The decision variable are the variables that will decide my output. They represent my ultimate solution to solve any problems. We first need to identify the decision variables. For the above example, the total number of units A and B denoted by X and Y respectively are my decision variables. Objective functions, it is defined as the objective of making decisions. And in the above example, the company wishes to increase the total profit represented by Z. So profit is my objective functions. Constraints, the constraints or the restrictions or limitation on the decision variables. They usually limit, that means here choco and milk is available is some restricted amount only. They usually limit the value of a decision variables. In the above example, the limit on the availability of resources, milk and choco are my constraints. Non-negativity restrictions. For all linear programs, the decision variables should always take non-negative values. This means the value for decision variables should be greater than or equal to 0. The process of formulating linear programming problems. Let us look the steps defining linear programming problem generally. Here, identify the decision variables, write the objective functions, mention the constraints, explicitly state the non-negativity constraint restrictions we have done before. Here, for the problems to be linear programming problem, the decision variables, objective functions, and constraints will have to be linear function. If all 3 conditions are satisfied, it is called linear programming problem. By using these 3 equations, we can solve the problem that will be explained in using some other problems in next video. Thanks for analyticvidya.com. So far we discussed about how to make a LPP, that is linear programming problems, equations, and we explain the various terms in this LPP. We have done. Please subscribe our YouTube channel.